So yesterday we talked about the rules of exponents, and I know you've been working with the rules of exponents for a couple weeks now, but every time we have had rules of exponents, we've only been talking about exponents that are integers. In other words, they are whole numbers. Now we've had negative exponents, we've had positive exponents, but all of the exponents we have dealt with have been integers, whole numbers. Today, we're going to start applying these rules to fractional exponents. Now, the rules of exponents and being able to apply them is very much going to be on the test, so to speak. However, being able to apply fractional exponents will not be. Okay? Doesn't mean you shouldn't know it. It'll be on a test at some point, just not in this class. Okay, so that is what we're going to be talking about today. Fractional exponents. So in the last couple days, we have had, or last weeks rather, we have talked about several different types of rules governing exponents. These rules are not going to change. We've gone through all of them. Now you're going to be asked to apply them just when you have fractions. All right, so here we go. Suppose a certain amoeba population quadruples every week. Quadruple means it is multiplied by 4. All right. So if you start with one amoeba, the population y grows according to the relationship y is equal to 4x. The graph of this relationship appears below. Ta-da! And so we want to know how many amoebas can be found in this population. If we start at one amoeba and it quadruples every week, how many amoebas can be found in this population after half a week? Well, let's take a look at this. I want you to take out your calculator right now, and I want you to actually do 4 to the 1/2 power. Now, your calculators probably are not going to love a fraction in the exponent, so this would be just as good if you had 4 to the 0.5 power, because 0.5 and 1/2 are equivalent. And what do you get when you type this into your calculator? You get 2. So the question becomes, what is really happening here? What is happening here? What do you think, Gavin?
When you have an exponent of 1/2, you are also dividing by 2.
Dividing by 2? Okay, dividing by 2 maybe. Anyone else think something different?
Well, it's basically when you do 4 times 1/2, you're basically just taking half of the 4 and making 2. So like half 10 just dividing.
Okay, so dividing by 2. Let's take this to the test. Let's see if it is really dividing by 2. So given your what you're postulating, if I have 16 to the 1/2, the answer should be
8.
Go ahead and give it a try. Let's see what we get.
It doesn't work. 4. It's squared.
You get 4.
It's
Ah. So really what's happening when we are taking a base to 1/2? What are we really actually doing in this problem, Luke? We're finding the square root. So 16 to the 1/2 is equivalent to saying the square root of 16. Okay? Let's try something similar. Let's say we have 8, and we're taking it to the 1/3 power. What are we really trying to do here? The cubed root. So what is 8 to the 1/3 power?
2.
It's 2. Because 2 times 2 times 2 is 8. Okay. And we can write this using the same square root symbol, but to show that you want the cube root, you would put a 3 here. And your calculator probably has a button somewhere that looks like this, so that you can find any root of a number. Yes, Gavin?
My calculator doesn't have that. It has like the square root with a little box next to it.
Yes, same basic idea. All right, so is everyone with us? We're talking about fractional exponents, and the number in the denominator is going to act as a square root or a cube root or a fourth root. Yes, Trevor? Oh, sorry, it's just 2. I'm sorry. I'm trying to confuse Blake, really. This video is for Blake.
Hi, Blake.
Okay, I'll count 3. 1, 2, 3.
Hi, Blake.
Okay. So now you feel loved by your class. All right. Thank you for catching that, Trevor. I do appreciate that. All right. So here we go. We have this nice long reading which essentially says the same thing we just talked about with the cubed root of 8 and the nth root. So there we go. Here's what you're going to be asked to do. We're trying to figure out if all the other rules of exponents apply to exponents that are fractions. That's all we're doing today. If it's not a rule, if it is a rule, it's probably going to work. So on question A, you have this problem right here, 16 to the 2/3 power, and you have 3 students who solved it in different ways. You are to look at these 3 methods of solving the problem and decide, do they make sense? If they don't make sense, why not? If they do make sense, why do they make sense? In question A2, you are simply taking these numbers to their fractional exponent. In question B, you have 4 problems that are applying different rules of exponents, and you are to apply the rule. In question C, you have 2 equations that you may recognize from our first couple investigations with the chessboard and the pennies. D, you have another equation. You're asked to find out if they are equivalent. And finally, in question E, you are applying the fractional exponent to variable expressions. The name of the game is apply the rules of exponents. Are there any questions about what I'm asking you to do? Okay. In that case, please get started. Have your homework out in front of you so that I may check it. And finally, before you totally get going, how many people actually looked at the answers that were posted on Edmodo for your homework? I did. No, you're supposed to after, not before. So after you finish your homework, you should check your answers. They are posted on Edmodo.